Hey everyone, I hope you're all having a great week. We had a really big August Exercism. We merged Premium and Insiders. We added automated feedback directly into our online editor. We launched track trophies, which I'll talk more about in a second. And we've made loads of small improvements to the site in general too. If you've not yet checked out your track trophies to see which ones you've got, definitely go and do that. I'll be sending everyone out an email after I've recorded this, actually. So you'll probably have got it by the time you're watching this. I'll be telling you which tracks you've got trophies in. So do go and explore that. During August, we also had loads of fun in 12 and 23. We were exploring languages in which people normally create apps. There were a lot of those languages. Erik recorded an amazing video on those. Do check that out if you missed it. But this month, for September, we're moving on to Slimline September, in which we're exploring languages that tend to be very concise and terse in their syntax. And specifically, we're looking at 8th, which is a descendant of 4th, if you get the pun. AWK, Bash, JQ, Perl, and Raku, which used to be known as Perl 6, but diverged. As always, you can earn the Slimline September badge by completing any 5 exercises in these languages. But we also have the year-long 12 and 23 badge that I know many of you are working towards. And for those, we've got 5 featured exercises that you can complete anytime during this year, as long as you complete them in one of these languages. And those are Gigasecond, in which you get to explore date processing, @bash cipher, where you can explore string processing in these languages, darts, which focuses on numbers and on conditionals, lun, which brings some of that together, strings, conditionals, and numbers, and then finally series, in which you get to work with sequences as well as strings. So as normal, in this video, Erik's going to be giving us a quick introduction to all of those languages. And we'll be exploring what makes them great, what makes them interesting, what makes them different, and then which one you should choose. So let's hand straight over to Erik with a bit of a summary of each language to get us started. And we're going to start with 8th. Hi, Erik.
Hi, Jeremy. So let's dig into these languages, and starting with 8th.
Cool.
So the 8th language was developed by Ron Aaron. Its name is, as you mentioned, it's like a pun on the 4th language, because it shares a lot of the same characteristics as 4th, so it's a descendant, but there are also big differences. And probably the biggest difference is that unlike 4th, 8th is strongly typed. So 4th is a dynamic language, but 8th deviates from that, so it adds strong typing. It's also a cross-platform language, and it has improved security, which means that a lot of the features in 4th that were maybe a bit iffy regarding to security, they just omitted it, trying to make it as safe as a language as they could. It's somewhat different from other languages in that it has both a free and a commercial version too. If you buy the commercial version, you get more features, but you can still use the free version. But it's a different model from a lot of other languages. Mm-hmm. As a consequence, it's also closed source, so you can't just look at the source code unless you buy an enterprise license, in which case you are allowed to view the source code under an NDA. I've not yet seen it myself, but it's interesting how you can see that you can also market a language, I think.
Nice, fun. And we had to get a copy of some of that, I think, for the test runner. There was some complications for us around that when we were trying to build that out.
Yeah, that was fun to build.
Yeah. Okay, cool. Short and sweet. Next up, AWK.
AWK. AWK was created at Bell Labs in the 1970s by Alfred Aho, Peter Weinberger, and Brian Kernighan. So the name is, I emphasize their surnames, because the name is an acronym of their surname. So Aho, Weinberger, Kernighan is AWK, or AWK, but you pronounce it AWK like the bird. It's a domain-specific language designed to do text processing. So if you're not familiar with domain-specific languages, these are languages that are specifically designed to be good at a single purpose. And in this case, that's text processing. It doesn't mean that they can only do that. This is also not the case for AWK. AWK can be used for a wide variety of purposes. but you can see in the design of the language that its original goal is to be great at text processing. And what makes it great, we'll get to later on. AWK is a Unix filter, which is like a tool that you can use in a pipeline on Unix. And examples are sed and grep, which are often used in conjunction with other commands. So for example, if you want to find something in your history, you do history pipe grep, but you can also do history pipe awk. And awk is used in these typical Unix pipelines. And it is actually part of the single Unix specification and the Linux standard base, which are like definitions of what implementations of those OSs should adhere to. So you find, therefore, that awk's implemented in virtually any Unix or Linux distribution. So if you know awk, you can apply that to any variety of star NIX system that you use. awk is it's a language, and there's also a tool which is also called awk that implements the language. But as it is common in IT, there are multiple implementations. So the original implementation is often referred to as, well, just plain awk or original awk or OAwk, which is fairly old and was the first version, of course. But later on in 1988, GNU-awk or GAWK was released, and that significantly revised and expanded upon the language. So it has more features than the original version. You also have BWK-awk, also known as NAWK, which was released in the late 90s. And you have MAWK, which is with a very fast bytecode interpreted implementation. And there are even more, but I just wanted to mention some of the bigger ones. But the thing that you need to know is that on most Unix systems, if you type awk, it will be a symlink to either GAWK or NAWK, usually GAWK. So you probably won't be using the original awk implementation, but a later version of it. The places where awk is being used is obviously where you are working with text. So if you do data extraction, if you do reporting, but also scripting in general, awk is really, really useful for you.
Nice. Yeah, it's a classic language. Excited to hear more about it in a minute. So next up we have Bash.
Another classic language, Bash.
Another classic.
Yeah, absolutely. They go well hand in hand too, but let's focus on Bash first. Bash is a Unix shell that was developed by Brian Fox and released in 1989. And it was designed as a free replacement for the Bourne shell, which was the default shell at the time. It has been very successful, and it has become the default login shell for most Linux distributions, and also for a lot of Unix distributions too. It is a superset of the Bourne shell, so anything that you wrote that worked in the Bourne shell also works in Bash, but you can do more than you could in the Bourne shell. So it expands on the Bourne shell in a couple of ways. So you have brace expansion. I won't be going into that, but you can look it up. Command line completion, which is obviously really, really helpful if you do command line tooling. Signal handling, so responding to certain signals that you get. And there's even more that I can't just mention because there's a lot. It's a lot, but you just have to remember that if you've been writing Bourne shell, you can just use that same source code in Bash, and then you can expand on it with the new features. The usage where you see Bash being used is primarily in system administration, so everything that goes with that, but also CLI utilities or wrappers around other CLI tools. You can use it to do DevOps. You can use it to do basically anything that you want to be automated. And we've actually used it tons while working on Exercism itself, especially in when we did V3, where we had to do a lot of cross-track PRing, and we used Bash all over the place. So Bash scripts, and another couple of languages that we are going to mention right next to this were being used extensively throughout the Exercism V3 development.
And Bash is another one of these sort of weird, almost feels like hybrids, where you see Bash as the shell that you're acting in, but it is also a full Turing complete language as well. And so it's not just a matter of it being something you write commands into. You can write, fully fledged programs in there as well. JQ.
JQ. JQ was developed by Stephen Dolan and released in 2012. So it's a relatively new language. And that's not a coincidence, because JQ was designed to work with JSON data, and JSON is also relatively new. And JQ's goals were to allow for very easy querying, transforming, and manipulation of JSON documents. And it's sometimes also being referred to as set for JSON, because set is great for processing just plain text files, but for JSON, not so much. But then we have JQ, and JQ stepped in that void and built something that made working with JSON a breeze. And like Bash, JQ is not only a language, but it's also a tool. So the tool that implements the language was originally implemented in Haskell, but once it was released, it was quickly rewritten to C for performance benefits. There are other ports too. So there is a Go-based one and a Rust-based one, but most people use the normal C-based JQ tool. Where would you see JQ being used? Well, anywhere you want to manipulate data, JSON data via a command line. So if you want to query data, just extracting some information, what I just mentioned, where we used Bash to work with all these Exercism repos, we also use JQ. So all the track metadata is on GitHub, and we use Bash to download files, and then use JQ to extract bits and pieces from that. We've also used JQ to add new exercises, so to update, manipulate JSON, and it all works really well. So you see a lot of shell scripts where JQ is being used, but also to just explore JSON data a bit. So if you have a JSON document and you just want to run some queries on it to get some data, JQ is perfect for that.
Yeah, we often use it in test runners as well, where you get some data that comes out of the test runner and we want to manipulate it so it's in the correct specification for Exercism, and you can just run a little bit of JQ just to remanipulate that data around. Okay, next up we have Perl.
Yeah, so Perl, another stable language, was developed by Larry Wall in the late 1980s. Its first release was in 1987, so quite a while back. And it was designed as a general purpose scripting language, specifically to make report processing easier, so processing text basically. And Perl has been very influential. In particular, its regular expression support. We'll come back to that later. But if you know Perl, you probably know that it's very famous for its regular expressions. And even if you don't know Perl, you might have been using it, but let's postpone that for a little bit. And the places where Perl is being used are, for example, for data manipulation, so working with text files, parsing files, web programming, especially in the beginning of the early days of the web. You had CGI, where a web server got a request and it would basically shell out to a different command to actually handle the processing of the request. And Perl was being used a lot in the beginning of the web to handle requests and to work with strings, because, well, HTML is basically just strings. And Perl also had an extensive module ecosystem, which was great for the beginning of the web, where a lot of the tooling was already available, so people don't have to build everything. So a lot of different places. System administration, of course, is quite important. So Perl is being used to administer systems all over the place in a wide variety of places. And you can do more stuff with Perl, but I think these are the key parts where Perl's being used.
And I think Perl has a bit of an esoteric reputation, where it's, you can look at some Perl code and it just makes no sense at a glance to you at all, and it's very much like you either know Perl or you don't. So I think a lot of people, I remember myself starting out in coding, or probably young age, seeing Perl and that being like magic that I wanted to learn. It was like, how does all this work? It just felt Yeah, it felt very sort of terse, very concise, very esoteric. So if you haven't played with Perl before, definitely feels like you're learning some sort of weird magic spells when you're doing stuff, which, as you say, fits with regular expressions as well, which is something else a lot of people see and they're like, oh, I want to learn this just because it looks cool. And then Perl 6 came along, and then this was the first language we ever had to rename on Exercism, I think. So yeah, this tested some of our scriptability, but yeah, now known as Raku.
Yeah, so Larry Wall, the same person who designed and built Perl, was working on Perl 6. And at some point, Perl 6 was just meant to be a release that cleaned up a lot of stuff. So reducing some of the craft and things that might not be as useful right now as they were. So there was a fun quote that I came across where Larry Wall said, in Perl 6, we decided it would be better to fix the language than the user. So I think that's a good observation. It's hard to update everybody instead of the language itself. But unfortunately, it took quite a long while for Perl 6 to be developed. And in the meantime, people were just aching for bugs to be fixed, for features to be added. So development on Perl 5 continued. And at some point, the language became source incompatible. So it used to be that any Perl 5 code would be valid Perl 6 code, but at a certain point, it wasn't anymore. And Larry Wall basically decided that, hey, these are just two different languages now, and they can coexist. And they renamed Perl 6 to Raku, and now they go their separate ways. And there has been talk of a Perl 7, although it's not there yet. So I don't think they are yet working on it. But it's a different language. Of course, it is very similar to Perl, but it is not entirely the same language because it is incompatible. The line design philosophy of Raku centers around making programming enjoyable and productive, but also to provide the user with a wide variety of different ways in which you can approach things. It's a true general purpose language, like Perl is too. Raku 2 is a specification, so there can and there are multiple implementations. That said, the only actively maintained implementation right now that, as far as I could tell, was Rakudo. But there are other implementations, older implementations, like Pugs, which was written in Haskell. Funny to see Haskell mentioned again. There was V6- Perl 6. I don't know where they come up with that name. And there was a Nixa, which was actually targeting the CLR, so you could run on the .NET platform. But you can see that there was a specification, so people tried to implement it, but I think most of the people right now are just using Rakudo. So where is Raku being used? Well, basically in the same places that Perl would be used. So processing text files, data, system administration, maybe a bit of web. So it has a very similar niche, but there's a bit more where Raku is also designed well to work with parsing structured text like grammars, for example, programming languages, but it could also be other things. But we'll get to that later on. And that's a very neat feature of Raku.
How many people have moved from Perl to Raku? Do you know? Has it shifted quite a lot?
I have no idea, actually. I think it's a friendlier split than Python 2.3, but the Perl community in general is quite friendly, so maybe that goes with the territory then. But I would be hard-pressed to have actual numbers or something like that, but maybe something more, somebody who's more into the Perl/Raku world could tell you. Okay. Leave a comment on the video.
Yeah, leave a comment on the video. Good shout. So next up, we're going to look at how these languages are different from a programming perspective, different paradigms they use, that sort of thing. So Erik, starting again with 8. In fact, do you want to give us a summary? What are they like as a group of languages first? What do they have in common?
Yeah. So as you might have already guessed, most of these languages are script-like languages where you often use them for short scripts. And those languages tend to be very dynamic because you don't want the overhead of a typing system where you have to, maybe think a bit more on how you design your program. You just want to explore stuff and try out things. And that holds for these languages too, mostly. So I think all of the languages except for one are, and one has a bit of an intermediate. They are dynamically typed and not statically typed. So this is all very dynamic. But let's go into the language in detail, and then we'll see where the exceptions are. So let's start with 8, which is the exception because it is strongly typed. It is also a multi-paradigm language, so you can use different programming styles. But this is by far the most weird or interesting, it depends on your viewpoint, language of the bunch, where it has a procedural paradigm support, so you all know that. But it also has different paradigms that you might not be familiar with, like being stack-based, which means that it has a stack-based execution model. We'll get to that later on. It is reflective, where you can introspect code and behavior, but you can also change it at runtime. And it is concatenative. I hadn't heard of the concatenative paradigm being used much, but it basically means that all the expressions are functions. And if you just put a bunch of functions after each other, that is function composition. So that implies calling the first function, then the second, then the third. You don't have to do anything explicit to say that I am calling this function. That is implicit. And that makes it a lot shorter. So that's absolutely why it is on this list too. 8 is compiled to native code. It's also slightly different from the others, but it can be interpreted in a REPL. So, but it compiles to native code, and that's different. Nice. Absolutely.
Yeah. Cool. And awk?
Awk is like the other language more. It's dynamically typed and is usually interpreted. Although there are implementations that do different things, so you could have a bytecode interpreter, for example. But in general, it's just a plain dynamic interpreted language. And its main paradigm is also a bit different. So we have the two more weirder languages at the beginning, where the main paradigm is data-driven. And in data-driven, a program is basically a set of statements, and statements are they describe the data to be matched and the processing that needs to happen if the match is applied, if it is true. And that's quite a bit different from describing a program just as a set of steps to be taken. Of course, you can think of this more as a set of rules that you need to, you describe the pattern, and then you describe the behavior that goes with it. But the order is, it is of course important, but it is somewhat less important than you would have in a typical language. So it works quite differently, and I'll mention some of the differences later on. But it does also support procedural programming, so you can do your imperative and your functions, etc. But the main focus is on the data-driven paradigm, which makes awk a really unique language.
Interesting. And then Bash, which, despite how weird it feels to write in, I guess is one of the more normal languages.
I was just about to say that. So Bash is blissfully normal. It is dynamic, it is interpreted, and it supports imperative and procedural programming. So it is a very familiar base for many people, I think.
JQ?
JQ is also dynamic and interpreted. Its paradigm is different from the others in that it is a functional language. It's even a purely functional language, where, sort of, whereas at least all values are immutable. So the functional paradigm in JQ focuses very much on pipelines, which is very Unixy, where you have data and then you do something with it and you push it to something else, and that will continue processing. That's also very much the JQ philosophy. So it is a functional paradigm with an emphasis on pipelines.
And just to stay on JQ for a second, how much of stuff in JQ is everything in JQ to do with JSON? Are you always structuring things as JSON when you're writing programs?
You can output strings too. So you don't, but strings are also JSON. So yeah. So I think yes and no, basically, because JSON just works with the JSON data. JQ works with the JSON data types, but those are also very much your common data types that you find in other languages. So You can output basically whatever. So you can output a string with quotes, but if you output the string without quotes, you can return it in any format you'd like. So I don't know, you could output binary if you'd like, but I don't think that will be really helpful. But you would output binary as zeros and ones instead of writing it to a file, probably.
I was just thinking it might be interesting to try solving the same exercise in Bash and in JQ to get a feel for how they're both dynamic and interpreted, but then you've got one that's imperative, one that's functional, slightly different data manipulation.
Yeah, and the way that people use JQ and also AWK, by the way, is very. It's also it's a very common use case where you just use them in very small one-liners, but maybe people don't realize that you can define functions in JQ and AWK. So there's a lot more to those languages than just what means the I. The same goes with Bash, but people are more comfortable with writing shell script. But with JQ, I had never written a function before. I just written all these little pipelines, and I didn't even know that I could define functions, etc.
Even with Bash, like probably 95% of the Bash I've written in my life has just been, a script calling out other things. I can't remember ever defining a function in Bash. Maybe I have, but it's not how I think of Bash when I use it. So it's interesting to think of it as a full language.
It's also interesting how you pass. Okay, let's continue.
We'll come back to it. Perl and Raku. Perl first.
So Perl is also dynamically typed and interpreted. It's a multi-paradigm language. It supports different paradigms. So it supports functional programming, object-oriented programming, and imperative programming. So this goes with the Perl philosophy of that there should be multiple ways in which you can do things. So Raku is sort of similar. It supports the same paradigms. It also dynamically typed and interpreted. But to add that, it has gradual typing. So gradual typing means that in dynamic typing, you don't specify the types, but you do in static typing. And gradual typing sits in the middle, where you can add types to some of your code. So you could say, hey, this parameter has a type that I know of. And the others you could just omit. So you can add typing where you feel it gives you value, and it enables something that I'll talk later on. That's also very cool.
A bit like what we were talking about last month when we were looking at sort of taking JavaScript and starting to add types to it via TypeScript and how that can sort of be a gradual process, but built more into the language. Cool. Okay, so next up, we're going to look at what makes each of these different programming languages great, what makes them interesting. So again, we'll start with 8th. Erik.
Right. So 8 has one of the reasons why it's great that it has very little syntax, which makes the language obviously easier to learn, easier to understand. It is really, really very little syntax. And it uses JSON to describe data. So you can see that this is a very modern language because JSON used to not even be there. And they've adopted JSON as the way to describe objects and arrays, but they also support other containers like stacks, queues, and heaps. But in essence, the syntax of 8 is there's very little of it, which makes learning the language easier. A very interesting aspect of 8 is that there are no reserved keywords. So in 8, what might people know as functions they call subroutines. It's somewhat an older word, but they don't call it subroutines, but they call it words. And a word you can just think of as a function. But the thing is, there are a set of predefined words, so you don't have to build everything from scratch, of course. But you can define new words, but you can also redefine existing ones. So if you decide that one of the built-in words is not working the way you want it to, you can just change it. And you're completely free to do that. So there are no reserved keywords. Nothing is special. So you define what you want to do with which word, basically. 8 is cross-platform, so you can easily generate an executable. I mentioned it's passed to native code, and you can compile it to a wide variety of platforms, so it's easy to ship in a very performant native code format. And then I mentioned before that 8 wants to be secure, so it has garbage collection, and it prevents access to memory, so you don't have pointers, no direct memory access. The runtime doesn't link to dynamic libraries, but it instead ships them into the with the runtime, so you can't just patch a dynamic library and just circumvent the security that way. So security is something that was built into 8 from the start.
I find it interesting to think about the no reserved keywords. So our maintainer of 8, the person that created the language in Exercism, in fact, is the same as the person that imported COBOL onto Exercism. And we were talking before about how COBOL has, I can't remember how many, but thousands of these sort of keywords or whatever that define the language. It's really interesting, like, to see the two different extents of that, but having the same person who's got an interest in both. I sort of like that.
Yeah, and many languages have implemented the 4th exercise. So, well, 4th was 8, the inspiration of 8, and the 4th exercise also has you redefine built-in keywords. So you can even try out 4th-ish functionality on one of your own, one of the other tracks on the Exercism. But do try out 8th because it's built for it.
Nice. Awk. What makes Awk great?
The first reason is quite similar to 8 in that it has very simple syntax. So it makes it easier to learn, easier to read. What Awk also has is a very fixed structure of your code. And we'll come to that in the standout bit. But just for now, you have to remember that in Awk, your code has a very specific structure, which makes reading different Awk code bases very easy because they will use the same structure. So you can reuse whatever you've learned in your own code. A second great feature is that Awk is very expressive, which means that you can do lots of things with very little code. And that makes it perfect for these one-liners where you want to read data from a file, just filter out a couple of records and then get the nth column of that and add it to some other column. And you can do that in very, very little code. You'd be impressed how little code you need. A third reason why Awk is great is that it is installed on most Nix machines, so Unix, Linux machines. You can also use it on your Mac. So your Awk skills are very portable. If you are working on one Linux system and you're moving to a Unix system, you can just use the same Awk knowledge that you already have, unless you depend on something very implementation specific. But in general, your skills are just really portable. And this, of course, makes sense because together with the Bourne shell, Binch, it's the only scripting language that is in standard Unix. So you see it all over the place. And because it's a standard, it's all over the place. So you can use it where you want.
Yeah.
And Awk works also really well in pipelines and shell scripts, where Awk is used to process the output of another command. And it is absolutely designed for that use case, and it works really, really well.
Nice. So on to its friend, Bash.
Bash. Like Awk, Bash can be used on most platforms. So it is installed on almost all Unix machines. It's also installed on macOS. And with Windows subsystem for Linux now gaining a lot of traction amongst developers, you can also use it on Windows systems. Bash is a REPL. So if you boot into the bin bash shell, you actually have a REPL where you can just run commands. And that's probably how the vast majority of people have already been interacting with Bash. So if you've ever used a Linux terminal, you have been writing Bash code. So if you type ls, that is a Bash statement. It's just that the Bash terminal is a REPL for the Bash language. But you don't have to write everything in the REPL. You can also write your Bash code in a file, and that's often referred to as a shell script. And bash can then read and run the commands within that file. And that's usually what you want if you have an automation task. So, which is the next point, that bash and shell scripts are great for system administration, for DevOps, for computer management. So we use it all over the place on Exercism too. It's used in a lot of our CI. So GitHub Actions use it a lot for tooling. There, if you download configlet, in most of the cases you'll be using a shell script. So it is very, very good for your system administration, where you just need to run a command, you need to do something else, etc. And bash makes it incredibly easy. The bash language itself is extremely versatile. It's highly dynamic and it's very flexible. So you can sort of mold bash into what you want. And it has very powerful string manipulation capabilities, including very straightforward string interpolation. So many people that have worked with bash will know that it's very easy to interpolate values into other values. And that is a really, really useful thing. So in general, bash is really powerful.
Nice. And then JQ?
Yeah, I keep on repeating myself, although bash doesn't necessarily have the simple syntax, but JQ does again. So like an awk, like an eighth, it has a very simple and short syntax for working with JSON, which makes it easy to learn again, easy to read, and makes it also great for these one-liners. But as I mentioned before, you can define custom functions. So it is not just a one-line language. You can write custom scripts that have functions and that use those functions like a proper functional language. And like a functional language, it supports tail recursion optimization. So tail calls can be optimized, which means that if you implement something in a recursive way and you do it in a very specific way, you won't have any of the negative downsides of repeatedly calling a function, which could lead to a stack overflow. But with tail recursion, you don't get that. So that's great for recursively processing data. What's really, really awesome about JQ is that it is distributed as a single binary. So the JQ binary is about 30-ish kilobytes. So that's incredibly small for such a powerful tool, and it makes it so easy to distribute. And you can even package it into your own application, because the C and the Go implementations, there's also a Go implementation, support being embedded in other applications. And one of the more interesting uses of not embedding but using the JQ tool is the YQ tool, which offers the same syntax for working with XML, TOML, and YAML files. And under the hood, what that tool will do is it will take the XML, it will use another tool to convert the XML to JSON, then it will run JQ on that JSON, and you get the feeling as if you were JQing XML, whereas in fact you would be under the hood just doing JQ on JSON. But YQ is a very useful tool if you want to do the same things that you can on JSON with JQ, but you want to apply it to XML, TOML, or YAML.
Nice. Do we use that at all on any of the stuff where we're using TOML?
I don't think we do actually, but we might. I could write a bash script to find out. But...
Cool. Okay. So next we're going to look at Perl, and then again we'll move on to Raku. What makes them great?
So Perl, like a bash and like an awk, runs on most platforms. So it is great for writing cross-platform scripts because you can use it in so many different places. What's really interesting about Perl is that it is designed to be very flexible. So Perl's famous motto is there's more than one way to do it, which is a very different motto from other languages. They usually try to encourage just there's one way to do things. Go is a language that is like that, where they encourage you to write things in a specific way, or maybe even you can only write it in one way. But Perl is like the other way around. It wants to encourage you to try out different things and to figure out what is the best way to solve this problem. and then for another problem you might do something else. And Perl is designed to be that flexible, so you can work in a lot of different ways with Perl. Perl has a very strong community, and it has a legacy of influential projects. So many scripts, tools, and applications have been developed in Perl, and it has often been said that Perl is the duct tape that holds the internet together. So especially in the early days of the internet, Perl was used a lot to glue things together, and many of those scripts will still be there running, just doing their work. So Perl is, even though you might not see it, it is still instrumental in running the internet as it is. And then finally, the Perl has a rich ecosystem of modules and libraries known as the Comprehensive Perl Archive Network, CPAN. So Perl is a relatively old language, so there's a lot of code that has already been written, and many of those bits of code will have been packaged as a library/module, and you can use those from the CPAN.
Raku?
Raku is like Perl. It's a big language where you can do stuff in a wide variety of languages. It is aimed to be the case that you don't have to use everything. You don't have to learn everything at once. So if you just want to work with Raku in a fairly straightforward way, you can do that. But once you get over that initial hump, you can try out the more complex features, and then you can sort of become more powerful in your uses of Raku. So it's very similar to the Perl the philosophy, where you can do things in different ways. The type system of Raku, as I mentioned before, includes gradual typing. So you can get the benefits of static typing, but only when you think it makes sense. So you don't have to use it. But there is a benefit of adding types, which is that you can use multiple dispatch, which we mentioned a really long time ago in Mechanical March of Analytical April with Julia. And if you ever heard of polymorphism, so it means that depending on the type of something, different things happen. But usually that's directly tied to objects and inheritance, etc. But it doesn't have to be. So multiple dispatch in Raku is defined on regular functions or methods, and you can define the types of the parameters, and based on the types of the parameters, the runtime will know which method to use to dispatch to. So it's a really powerful feature. And we mentioned this before in the Julia chart, so I won't go into details, but the gradual typing allows for this to happen, because you can't really do this well in a dynamic language that doesn't have any types. But so Unicode in Raku is a first-class citizen, like you would expect of a modern language. So native support for handling encodings, etc. And then finally, what I hadn't expected myself was that Raku is really into concurrency and parallelism. So it has built-in support for asynchronous programming, but also reactive programming and parallel execution. So it is very, very suitable for modern high-performance applications, which is not something that people would usually associate a Perl-like language with. But as Raku was fairly modern, very modern, it has incorporated these concurrency constructs in the language.
Nice. And so then, finally, looking at these from a program perspective, are there any sort of standout features? You've sort of mentioned bits and pieces, but focusing on that. So starting with 8. Yeah.
So 8 has what I think is really, really awesome is that it requires a different way of thinking. So the blend of paradigms that 8 support is really unique, and I don't think you see that in any other language. There might be bits and pieces of it, but not this unique combination. So the stack-based approach with the concatenative I don't know if that's the right word, but at least the different paradigms allow you to program in a way, or require you to program in a way that is very different from what you might be used to. And I've always found that once you learn a new language and you have to do something differently, I found it really invigorating because I have to learn new things, and usually I become a better programmer as a result. So I think 8th has a lot of that goodness, where it just offers something that's really different. And zooming in a little bit on that is that the stack-based paradigm is obviously the most striking one, I think. And you've probably all heard of stacks and how they work, where you add things just to the top and then you pop things from the top. Working with a stack-based language means that you sort of see the stack-based implementation in the language. So you use a reverse Polish notation in 8th. So if you want to multiply two numbers, you push a number to the stack, you push another number to the stack, and then you push the multiplication operator to the stack. And at that point, the two values on the stack will be popped, and a new value will be pushed. And this is well, it's actually very similar to how your CPU works, but it's not similar to how many languages work. So it's called reverse Polish notation, so RPN. So look into that if you like. And it also makes for a very easy mental model, because you don't have something like parentheses, because it's just not there. It's just the order in which you push things on the stack and operators on the stack determines the precedence. So you don't have any precedence issues. It's just not there. And I think that's a really cool feature.
Yeah, same as what you were saying a bit earlier as well about like lining up functions and things. It gives that same ability to do that. Awk, what makes Awk really interesting programmatically?
To me, the most interesting part of Awk is its data-driven paradigm and the fact that it is really, really powerful. So it requires you also to think a bit differently from your programs. So where usually you have the steps, you now think of more like condition action pairs. So text is by default split into records. So usually the typical separator is a new line, but it can be anything you like. So normally if you have a text and you have 10 lines, it means you have 10 records within Awk, and Awk will iterate over all those records, and it will then try to see which condition action pairs match for those lines, and it will run the code. So the record is also, so a record is usually a single line, and that line is then split into fields, and the default separator is white space, but you can also do commas or whatever. But it means that all of a sudden, it just, if you have, for example, if you want to count all the words, that becomes incredibly easy, because Awk will do all the heavy lifting for you. It will parse the lines into records, it will parse the records into fields, and then you can just work with those fields. And if you want to output a single field, that's fine. If you want to only match a line if the third field is equal to true, that is incredibly easy. And the data-driven paradigm is really elegant. It's expressive and very powerful. And once you've gotten used to this a bit, you'll see these opportunities arise all over the place when you're working with processing data from other scripts. For example, you'll think, hey, I can use Awk to manipulate this a little bit so that I can use it in another command, or maybe to write something to the output that's really nice. And that sort of ties into my second point, which is that Awk is perfect for working with text. If you want to parse text, transform text, reporting, Awk has got you covered. So if you want to find out which shell each user is using on the system, that's like a teeny tiny one-liner. If you want to iterate over the columns in a CSV file, or why not sum a specific column in a CSV file, that is also just, I don't know, maybe 15 characters of code. It's just almost incredible what you can do with Awk in a one-liner. So if you want to work with text, structured text, do check out Awk.
And then Bash as the glue that fits Awk into the world.
so Bash is perfect for automation. So it's what we've been using it all over the place for. If you have a repetitive task and you want to automate it, it is very easy to write a shell script to do that. So that's also why Bash is so pervasive, because it is so easy to do repetitive tasks. And well, a lot of our programmers' lives are about automating repetitive tasks. So that's why Bash is such a useful language. Also, the fact that Bash has this Unix pipelines support that lets you glue programs together is what makes it really, really powerful. Especially when you combine the fact that it runs on Linux, where you have a plethora of all these tools that you can use, like a set, like a grep, but also ls, etc. So the power of Bash pairs really, really well with all the power of a Unix system or a Linux system, where you have all these tools, these little tools that do one thing well, and then you can link them up via Bash. You can write scripts. You can write scripts that, for example, make it very easy to stop the script when one of the commands that is executed fails. So you don't have to have the explicit error handling after each command that you call. You can just set a flag at the top and say, hey, if any of the called commands fail, the whole script should fail, which is something that in other languages you might have to manually do, but Bash just has you covered. So it's great for anything that has to do with automation or gluing together things, and it's a very powerful language as such.
And then the third of these manipulative languages, JQ.
Yeah, well, JQ is great for manipulating JSON data. So not only oftentimes JQ is used to query data, but you can manipulate data, so you can change things. What many people don't know is that you can actually also create JSON with JQ. So we use it in a couple of places too. And because JQ is so great at working with JSON data, it has sort of become the de facto tool to transform JSON data, at least from a command line perspective. Otherwise, you would use your built-in language tooling. But we sometimes even use JQ in favor of just writing, for example, I like maybe a C# script or a Ruby script, just because JQ is so easy and handles a lot of the cases really well, where you don't have to write a lot of code that you might otherwise have to write. And so that's absolutely one of the best things about JQ. Like a proper Unix tool, it supports working with streams or pipes, which means that you can work with infinite data. So usually there's no real infinite data, of course, but if you would process very large parts, very large JSON documents, you can do that in an efficient way, because it will sort of process them one by one instead of having everything in memory. So you don't have the memory issues that you might associate with working with infinite data. And that's a very neat feat of JQ. And then finally, this emphasis on writing your code as a series of pipelines. So within JQ itself, so you select the first field, then you select the nth element in the array, then you do a bit of filtering. That is something that is really familiar to everybody that has used a Linux or Unix system, but also, of course, to a lot of Windows developers or Mac developers. And this familiarity will be one of the reasons why people are often, they can pick up JQ fairly easily, because it fits well with the mental model of how a lot of other things also work.
Yeah, it seems like people pick it up very quickly and can be productive in it quite quickly. I've witnessed that a lot. Perl, what makes Perl interesting?
One of the things that makes it interesting is what you mentioned in the beginning, is that Perl is famous for its succinctness and its expressiveness. So you can do a lot of things with very little code. There are things like code golf exercises where you have to use as little code as possible to do a task, and Perl is fantastic for that. It's not always readable, but you can absolutely write very readable code. while still having the succinctness of Perl. So Perl allows you to do things in a lot of different ways, but usually there is at least one way to do it in a very short and concise way, where you have little code and it makes it easier to reason about the code. So that's absolutely a great aspect of Perl. A second aspect of Perl that really stands out is the ability to work with text. This is for a wide variety of reasons, but in a large part, it's due to its powerful regular expression support. In particular, Perl 5 introduced a lot of new features in the regular expression world, like back references, named capturing groups, lazy quantifiers, a lot of things that we take for granted were introduced by Perl 5, at least as far as my research shows me. And then Philip Hazel built PCRE, Perl Compatible Regular Expressions, which is a C library that implements the Perl 5 compatible regular expression engine. So if you want to use the features of Perl 5 in another language, you could use PCRE, but you can also, of course, just use Perl. But it goes to show that many new languages, even if they don't use the PCRE library, implement their regular expressions as PCRE compatible. So in C#, you have PCRE compatible regular expressions, which means that you can use the same syntax that you can use in Perl. And that's, of course, for a reason, because the Perl syntax is so incredibly powerful and is really, really useful, especially, of course, regular expressions are about working with text. So pairing those two means that Perl is excellent for working with text. And if you love regular expressions, you'll absolutely love Perl.
Yes. And then, of course, Raku shares, the same feature as Perl, but as a much newer language. I guess it's got lots of other stuff as well that makes it interesting.
Yeah, absolutely. So one of the things that it has, it's called, it's a very fancy name, auto-threading junctions. And we're not going to go into the details. But it basically means that you can sort of have parallelism without any of the issues. So any of the hard work, where you sort of give Raku like hints almost that you can do something in a parallel way. And you don't need to know the nitty-gritty details, and Raku will handle most of that for you. So they're a really powerful way to introduce parallelism into your code base. Another really cool standout feature of Raku is that it supports lazy evaluation, where you can work with infinite data, like what I mentioned with JQ, so without running into any memory issues. And this is especially useful if you use Raku to work with very large data sets, because loading that entire data set in memory might be too much for your system, whereas doing processing in a lazy way can maybe just be your regular memory usage, which would be very low, I guess, so without any out of memory issues. And that is one of the really standout features of Raku. Of course, Raku has the same regular expression standout features that Perl has. So it builds on that a little bit. It has some tweaks to it, where some of the things have been simplified a bit. So it's not entirely Perl 5 syntax. There are some changes. But more interesting, I think, than just the regular expression is the fact that Raku in general supports domain-specific languages. So you can define domain-specific languages, of which a regular expression is one, in your language using what's known as a grammar. So you can define rules. If you've ever seen a specification of a language, you might know that there will be a thing like an if statement is composed of a Boolean condition, then a then condition, and maybe an else. And then you would have a separate definition of what a Boolean condition is, etc. So you would have a list of rules that the text has to adhere to. And these are often called grammars. And in Raku, you can define these grammars within the language itself. And then you have automatic parsing of those grammars without having to write any of the code. So you can create parsers. Well, you don't actually create the parsers. You define the grammars for the parsers, and then Raku will handle everything for you. And that can be great for handling all sorts of complex textual data. It doesn't have to be a programming language that you parse. It can be your own proprietary data. And you can work with that in a very nice way without having to write all those not so fun to write wrapper code thingies.
That's really powerful. Okay, so that's our summary of the languages. I always like to ask Erik the question at this point. For all of you, try and decide which of those languages you're going to explore over this next month. Erik, which of these would you suggest that we try out? How should someone make the decision?
Yeah, try them all. Now, if you have the time, absolutely do that, because it's always fun to see how these languages are sort of similar, but also different. But if you're primarily using a Unix system or you're doing DevOps, I think Bash will be a very logical choice. It's an invaluable language to learn because it will be used all over the place. But learning an AWK or a Perl or a Raku on a Unix system also makes a lot of sense, because they also have you can put them in pipelines, etc. And Perl and AWK are pre-installed on most systems. So I think those 4 languages are, if you're very Unix or Linux minded, those are great languages to start with. Obviously, if you're working with JSON or XML or YAML or TOML, JQ is the natural fit, of course, because it wasn't built to work with JSON. If you want to process text, you can work with AWK, with Perl or Raku. They are really well suited to working with text. The other languages, you can do them too, but I think those 3 languages are the best at working with text, probably. And if you want to try something else entirely, so if you want to try a different paradigm, see what stack-based programming is, go try out 8th and see how your mind is blown, that you can do things in a completely different way and still have very succinct code.
Well, thanks so much, Erik. That was great. Really appreciate all of your hard work in that. I hope everyone has a great time exploring these languages. I really recommend digging in, especially AWK and JQ. I think if you've not come across those languages before, I think they're super interesting. But also, I feel like every programmer has to try Perl at some point and cut their teeth on that. But whatever you try, I hope you have a really great September. And don't forget to check out your track trophies as well. And look forward to seeing you on the forum or on Discord or around the Exercism ecosystem soon.